question number 56, which says that degree of hydrolysis for a salt of strong acid and a weak base is equal to. So you know that degree of hydrolysis is H, which is equal to under root of KH by C, where KH is the hydrolysis constant. And you must be knowing that for a salt of strong acid and a weak base, KH का expression क्या होता है? It is equal to KW by KB. So substitute in the first equation. So we will be having H is equal to under root KW by KB into C. So option number 1 will be the correct answer. So moving on to the next one, students, we have question number 57, which says that an ideal gas has specific heat at constant volume, which is CV. So it is equal to 3 by 2R. The gas is kept in a closed vessel of volume 0.0090 meter cube at a temperature of 300 Kelvin and pressure of 1.8 into 10 raised to the power 6 Newton per meter square. So if 2.8 into 10 raised to the power 4 joule of heat is supplied to the gas, then the final temperature of the gas will be. So here the 2.8 into 10 raised to the power 4 joule heat is supplied to the gas at constant volume. So we can write the expression that is heat supplied at constant volume, which is equal to NCV delta T, where N is the moles of the ideal gas. Okay? So now first you have to calculate the value of N. So you have been given an ideal gas. So you know the ideal gas equation, which is equal to PV is equals to nRT. ठीक है, तो यहाँ से N की वैल्यू कितनी हो जाएगी, which is equal to PV by RT. So the value of pressure we have been given is 1.8 into 10 raised to the power 6. And volume we have been given, that is 0.0090 divided by R into T. So the initial temperature is 300 Kelvin. Okay? So now use the value of N in the first equation. So the heat supplied is 2.8 into 10 raised to the power 4 joules. So which is equal to N. So the N की value we have been find out, that is 1.8 into 10 raised to the power 6 into 0.0090 divided by R into 300. ठीक है, into CV, which is equal to 3 by 2R into delta T. ठीक है, so if you calculate this, you will find the value of delta T here, which is equal to 345.68. ठीक है, and delta T we know that it is T2 minus T1. So T2 is the final temperature that we have to find out, and the T1 is the initial temperature, which is equal to 300. So which is equal to 345.68. So the T2 value will come out to be 645.68 Kelvin. So which is nearly equal to 646 Kelvin. So students, option number 1 will be the correct answer. So moving on to the next one, we have question number 58, which says that the favorable conditions for the reaction are. So you have been given a reaction where 2H gas, which are the atoms of hydrogen, is in equilibrium with H2 gas. ठीक है, so first of all we will determine the role of the pressure. So अगर हम pressure को increase करते हैं, so the reaction will move in that direction where the number of moles of the gaseous species are less. So अगर हम यहाँ पे देखते हैं, in the product side we have number of moles of gaseous species less, so the reaction will move in the forward direction if we will increase the pressure. So pressure increase करने से the reaction will move in the forward direction. ठीक है, now determine the role of temperature. अगर हमें H2 molecules को break करना है to form the hydrogen atoms, it means we have to supply the energy. So it means the backward direction in which the H2 gas is forming 2H gas, means it is the reverse reaction is the endothermic reaction. So the forward reaction will be exothermic. और अगर exothermic की हम बात करते हैं तो decrease in temperature will favor the forward reaction. तो अगर हम temperature decrease करते हैं so the reaction will move in the forward direction. So the favorable conditions are low temperature and high pressure for this reaction. So option number 4 will be the correct answer. So moving on to the next one, we have question number 59, which says that what would be the pH at the equivalence point for the titration of equal volumes of 0.10 molar KH2BO3 with 0.1 molar HCl. So first of all, write down the reaction between KH2BO3 plus HCl. ठीक है, तो ये क्या बनेगा? It will form KCl plus H3BO3, which is the orthoboric acid. अब now you have been given 0.10 molar of KH2BO3 and suppose volume is V liter, and for HCl it is 0.1 molar and the volume was same, that is V liter. ठीक है, अब अगर यहाँ पे हम moles निकालते हैं तो it will be equal to molarity into volume, so which will be equal to 0.1 V, और यहाँ पे भी HCl की क्या हो जाएगा? 0.1 V. ठीक है, अब we have to find out the pH at the equivalence point. So equivalence point का क्या मतलब होता है? So equivalence point पर the reaction will be completely neutralized. So यहाँ पे दोनों के moles क्या हो जाएंगे? Consumed. Fine. So यहाँ पे कितने moles बनेंगे H3BO3 के? 0.1 V. Fine. So the concentration of H3BO3 will be equal to moles 0.1 V divided by total volume. So total volume is 2 V now. So the concentration will be 0.05 molar. ठीक है, so now we have the weak acid with us. So weak acid के लिए now we have to calculate the value of pH. So we know that H plus concentration, which is equal to C alpha, and it is a monobasic acid, so it will be equal to Ka into C. ठीक है, so pH का क्या फॉर्मूला होता है? pH is equal to minus log of H plus. So it will be equal to minus log of Ka minus log of C whole to the power half. ठीक है, तो यहाँ पे pH की वैल्यू कितनी हो जाएगी? It will be equal to half of minus log of Ka minus half of log C. अब minus log of K क्या होता है? It is pKa. So we can write it like this: pH is equal to half of pKa minus half of log C. ठीक है, so pKa की वैल्यू में कितनी थी? It is 11.086. So substitute here half into 11.086 minus half log C. So concentration is 0.05. So if you calculate this, your answer will come out to be 6.193, which is nearly equal to 6.2. So option number 1 will be the correct answer. So moving on to the next one. So we have question number 60, which says that which of the following is not a conjugate acid-base pair. So the conjugate acid-base pair differs only by one proton. Suppose you have a conjugate acid so if it loses one H plus, it will form the conjugate base, and if the conjugate base accepts one H plus, it will form the conjugate acid. So in the first case you have NH4 plus. ठीक है, अब अगर हम NH4 plus का conjugate base करते हैं, means it will lose one H plus, so it will form NH3. So we can say that this is a conjugate acid base pair. Fine. Now you have in the second one H3O plus. So if it lose one H plus, it will form water. So if water now loses one H plus, it will form OH negative. So water and OH negative are conjugate acid base pair, but not the H3O plus and OH negative. So this is not the acid base pair. Now we have in the third one, suppose you have HF. If it loses one H plus, it will form F negative. So we can say that HF and F negative are conjugate acid base pair. And now you have in the fourth one, we have CH3COOH. So if it loses one H plus, it will form the conjugate base, that is CH3COO negative. So they also are conjugate acid base pair. So the only incorrect one, that is option number 2. So moving on to the next one.